This is a video to go over lesson 2.8, which is the derivative of as an actual function. So today we're going to be sketching the derivative function given a graph of f of x. So I have one example to go over with you guys to start. Here's a function y equals f of x. Looks like some sort of parabola function, perhaps. Maybe a degree 4 parabola. I've labeled it with different colors for a reason. So we're going to be sketching the slope of this curve for different x values. And we have to keep in mind where the function is decreasing and where it's increasing, because that's going to tell us where the slope is positive and where it's negative. So for example, for this beginning part of the function, until we get to, let's say, 0.5 here, the function is decreasing, which means the tangent line would have a negative slope. That's why I've labeled it in blue. So in blue, f of x is decreasing. So f prime of x would be negative or less than 0. So that's what I've got in blue here. So this other blue region, same thing. The graph is going down, it's decreasing, so the tangent line would be negative. So for example, if you were to draw the actual tangent line at a specific point here, you can see it has a negative slope. For the parts in yellow, the slope is positive because the function is increasing. So if you were to draw the tangent line, it would have a positive slope. So for the points in yellow, increasing. The first few times you do these, you can use this color trick to help you visualize it if that helps you. You don't have to do the highlighting, but I find that it helps. Now in between where it switches from negative to positive, we have these points here that are sort of minimums or maximums on our curve. Right? We have this minimum valley here, and then we have a maximum, like a peak in our graph, and then we have another minimum here. At those points, if you were to draw the tangent line, and I'm using red for my tangent lines, it would be a horizontal line. So that means it has a slope of 0. So the first thing you want to do when you're sketching your derivative function is to draw those 0 points. So step number 1 is to show where the slope is 0. So I'm going to just draw the x values here. So here's x equals 1. So it's 0 at 0.5. It's 0, it looks like maybe about here. And then 0 again about here. Okay. And then in between those points, we have to show what's happening to the slope. So let's look at the first part of the graph. The slope is negative, remember, and it starts out quite steep. And then it gets shallower and shallower and shallower as we move into that, that valley there. So it could look something like this. Okay, so it's large and negative at the beginning where it's quite steep, and then the slope, the value of the slope gets less and less and less and less. So remember here, the y value on this graph, when we're graphing f prime of x, it represents the slope of the tangent line. Okay, then at x equals 0.5, it is 0. Now what happens is the slope becomes positive, and it looks like it's quite steep at 1. So it gets larger and larger and larger. It gets 1, and then it gets shallower and shallower and shallower as we go back down. So maybe something like this. Okay. So again, the slope was negative in this region, so that's why it's below the x-axis. The slope was positive with its steepest point probably being at x equals 1, and then heading back down towards 0. And now in this next region, the slope is negative. It gets steepest maybe around here, and then it flattens out again. So maybe something like this. Okay, so this was the blue region from my graph. And then the slope is positive in this yellow region. It just gets steeper and steeper and steeper. So I'm just going to draw my line going up and up and up like that. So that's the graph of the slope function. So each y value on this derivative curve would represent the slope on the original function of the original function. Okay, I have a video to show you guys later where you go through more examples if you need them. Okay, there are some points where a function would not be differentiable. Not differentiable means that it does not have a slope of the tangent line. There's no tangent line slope at that point. So not differentiable means the tangent line does not have a defined slope. So there's 3 examples where this can happen. A corner. So when you have a sharp corner, okay, there's no way to draw the tangent line. So the slope of the tangent line, you can't say what it is at that corner point. Okay. Discontinuity, so a jump has no slope at the jump point because, again, you can't draw a tangent line since you don't know whether to draw it from the left or from the right. And the third time when you do not have a defined slope is when you have a vertical tangent line. That's because vertical slopes of vertical lines are undefined. So those are the 3 times when you would not have a derivative at a certain point. Okay, let's try and do one more example here where we draw the derivative. And then that will be the end of today's lesson. So here we have a straight line. We've got a corner here, a sharp corner at x equals 0. So this function does not have a defined slope of its tangent line at x equals 0 because of that corner. But it does have a slope for x values less than 0. The slope here is actually -1. So it's a constant slope. And then the slope of the line for x is greater than 0 is 1. So to draw the graph of f prime of x, we just have to do the following. For x values less than 0, the slope is always -1. And then for x values greater than 0, it's always +1. My hand is shaky, so those don't look like straight lines, but they are straight lines. Okay, there we go. So if we were reading this graph off, every point less than 0 reads off as -1, and then every point greater than 0 reads off as +1. And the question also asks, where is this graph not differentiable, meaning it does not have a derivative? It does not have a derivative at x equals 0. That's because it's a corner. And so notice that I put open circles here because the derivative is not defined. So I can't color in those circles. There's no slope at x equals 0. Okay, so that is it. However, I'm going to post another video if you guys need more examples of how to draw the slope function. I'm going to post another video on Teams. So look out for a Khan Academy video posted on Teams. If you want, you can just try the assignment and see how far you get, and if you need some extra help, then you can watch this Khan Academy video. All right.